So last unit we looked at functions and relations. This unit we're going to look strictly at linear lines and the properties of lines and look into a little bit more detail than what we looked at before. First we're going to look at slope. We've talked about slope already. We know a couple of things about different types of lines. For instance, we know that this slope has a positive value. We know that this one has a negative value. And we know that this one has a 0 value when we have a horizontal line. We also know that the slope for a vertical line is undefined. These are all things that we looked at last unit and we talked about in the general sense. Positive slope as we go towards the x values positively, our y values are going up. So it's a positive over positive, which makes it a positive slope. In the negative aspect, as we go to the positive, our y values go more negative. So positive or negatives, either way you look at it, whether you go down or over and down, either way you're going to get a negative value for your slope. Whereas here we have 0 rise over our run, and here, well, we have a rise, but we don't have a run, so it's undefined because we're dividing by 0. So a formal definition of slope and some things that you'll need to know about it. Slope is now going to be referred to as the variable m. Whenever you see m in a line, that is what we're referring to. We have seen this already, and we talked about this and we said y equals some constant times x plus another value. Our m was our slope and our b was our y-intercept. So this should all be reviewed from what we looked at last unit. But again, formalizing this. Now we can write that m is going to be your rise over your run, which we talked about. Rise being your vertical y values, run being your horizontal x values. So your rise over your run. Another way to look at this, you can also write it as m is going to be your vertical change. So the change in your y values all over your horizontal change, and again the change in your x values. So if we start looking at this as our definition, we can now actually start doing it with ordered pairs. If we were to choose any 2 points on our lines, they have corresponding x and y values. So to find a vertical change, you're looking at the difference between the 2 y values, and the horizontal change will be the difference between the 2 x values. So let's make more space here and I'll show you what I mean. So let's say we were looking at these 2 points. We know that it is a positive slope because as you go towards the x positively, you are going increasing your y value, so it's a positive over a positive, so your slope is going to be positive. Now, what we can actually do with this in order to find your vertical change over your horizontal change, we can look at your 2 y values, y2 minus y1, and find the difference of those two and the difference of the 2 x values. Now I've used the letters y subscript 2 minus y subscript 1, x subscript 2, x subscript 1. It doesn't matter which point you refer to as your first point and your second point. What does matter is that you keep these guys as pairs. Whichever one you call number 2 is going to be your first one that you're subtracting from. So let's say in this case, let's call this one x1, y1. And let's call this one here x2, y2. If we use our formula, now I'm going to have my y2 subtract my y1. So negative 2 subtract positive 3 all over my x2, so negative 5 subtract positive 4. In this case now, I'm going to get negative 5 over negative 9, which then a positive or negative becomes a positive, so we're going to get 5 over 9. If I was to have chosen my variables from which one was x1 and y1 and x2 and y2 the other way around, I would have then had 3 minus negative 2 all over 4 minus negative 5. Then subtracting a negative is the same thing as plus, so 3 plus 2 all over 4 plus 5, which then is going to give you 5 over 9. So like I said, it doesn't matter which way you choose your variables, first point, second point, all that really matters is that you keep your y2 and your x2 first, and your y1, x1 as your second pair. Now again, if we look at our examples for when we have horizontal lines and vertical lines. When we have a horizontal line, we can use the same formula of y2 minus your y1, the difference in your two y's, over the difference in your two x's. And again, choosing them whichever way you like. Let's call this one x1, this one y1, x2, y2. First point, second point. So if I do y2, that's 3 minus, in this case, y1 is also 3. All over x2 is 3 minus negative 2. Your slope, m, is going to become 0 all over 5, which is then just going to simplify to 0. Hence, like we said, horizontal lines have a slope of 0. If I do the same thing for a vertical line, then let's call this one x1, y1, x2, y2, negative 4 subtract 3 all over negative 2 subtract negative 2. Now you're going to get negative 7 all over 0. This one, undefined. You cannot divide by 0. So if you're given just the point values instead of the actual line to look at, by using the formula again, you can verify whether it's horizontal or vertical just by looking at their slopes.